us do one more application based on Thayer's theorem, converse part of Thayer's theorem.
Please subscribe and don't forget to click the bell icon for the more updates.
We have given in triangle ABC, AB equal to AC. DE are midpoints of the sides A, are the points on, sorry, not midpoints, are the points on AB and AC. Okay, such that AD equal to AE. We have given here one more, that AD equal to AE. Okay, show that the points B, C, D, E are concyclic. Do you know this topic concyclic? What is meant by concyclic points? Exactly. Here, when suppose here this is a circle. Okay, if there are some points existing on, from your 9th standard topic we might have learned, this is A, this is B, this is C, this is D, and somewhere here E. Can you tell me what is the position of the points with respect to this circle? Yes, all the points are there on the circumference. Okay, if all the points are existing on the circumference of a circle, then they are said to be concyclic points. Okay, so these are called what? Concyclic. When, if suppose I will say this is E, okay, this is F, then can we say that A, B, C, D, E, F all are concyclic? No. If you leave F, then remaining all are concyclic. So it is clearly I am telling you, this is actually topic of 9th standard in any curriculum. Okay, from 9th standard we have learned that what is concyclic points. What are concyclic points? Concyclic point means the points which are existing, which lies on circumference of circle. On the circumference of circle, if some points are there, those are called concyclic points. So we need to show that this B, this C, this D, this D and this E all are lying, all lies on the circumference of one circle. That is our target. Okay, and one more thing I have to tell you. I want to tell you, suppose here before starting the problem we need to discuss the basics of cyclic quadrilaterals and all, because it is relevant to that. Okay, just see here, if it is a quadrilateral, is it a quadrilateral or not? Of course it might be trapezium or something else, but it is quadrilateral. Okay, if this quadrilateral, these all are the vertices are the points or not? If points, if vertices of quadrilateral are concyclic, see, that means what? Joining them we can draw one circle. This is not exactly looking like circle, but you can assume. Okay, now what can you say here? In this quadrilateral, okay, for this quadrilateral, all the vertices lies on circumference of one circle. Okay, circumference of a circle. Then can we say that all the vertices are concyclic or not? Absolutely. Okay, so if all the vertices are concyclic, it holds a property that also we have studied in the topic of cyclic quadrilaterals in your previous class. What is that property? Can you tell me? Okay, what is that property? If all the vertices of a quadrilateral, if all the vertices of a quadrilateral are concyclic, then that quadrilateral is said to be cyclic quadrilateral. Understood? That quadrilateral is said to be what? Cyclic quadrilateral. So we need to show that this ABCD is a cyclic quadrilateral. Then obviously BCDE, these all will be called concyclic, because all the vertices will be there on the circumference. Understood? So we need to show that this BCED quadrilateral is a cyclic quadrilateral. And what is the condition to be shown over there? What is the condition that it should hold to become a cyclic quadrilateral? That is also the topic of your previous class from cyclic quadrilateral. What did we prove over there? So here, if opposite angles are supplementary, that means what? Here, if A and CE are supplementary means what? Supplementary means some of them should be 180 degrees. And here also if B plus D equal to 180 degrees, then it is known as what? Cyclic quadrilateral. Right? So once again I am telling you, when can you say that a normal quadrilateral can be cyclic? Cyclic quadrilateral. Only small thing you need to show there is if opposite angles are supplementary, that means sum of the opposite angles is 180 degrees, then it's a cyclic quadrilateral. Simply that is the answer. Understood? So I think you might have known that what we need to do, what we need to prove in this problem to show that this B, C, E, D, all the points are concyclic. Once again I am repeating because this might be a bit confusing for those who are not aware of the geometry topic. Okay, just see, here we need to show that this B, this C, this E, this D, all the points are concyclic. When can it be possible? When you show that B, C, E, D is a cyclic quadrilateral. That means all the vertices should be on a circle. How to show that it's a cyclic quadrilateral? There is a rule. There is a property. What is that property? If opposite angles of any quadrilateral are supplementary, then that is a cyclic quadrilateral. So here, if A plus C is 180 degrees or B plus D is 180 degrees, obviously when one pair of opposite angles is 180 degrees, obviously second pair also will be 180 degrees because sum of all angles is 360 degrees in a quadrilateral, right? So here it is sufficient to show that angle C plus angle D or angle B plus angle E. See, if you consider this as a quadrilateral, this and this means B, C, E, D is a quadrilateral or not? Yes. Here it is sufficient to show that angle B plus angle E is equal to 180 degrees, or else you can take angle C plus angle D equal to 180 degrees. If you show one of them, another one will be obviously correct. Okay, if you show that angle C plus angle D equal to 180 degrees, then obviously this pair, sum of this opposite pair also will be 180 degrees because sum of the angles in a triangle is 360 degrees. Understood? Okay, so I think you might have understood that what we need to show. Finally, I am reminding you that we need to show that here that opposite angles in this quadrilateral B, C, E, D, opposite angles B and E are supplementary and C and D are supplementary, then this quadrilateral will be cyclic quadrilateral. When this is a cyclic quadrilateral, the vertices of those quadrilateral will be concyclic. That's it. Okay, so here we need to show that, just see. Okay, look at this. First of all, we need to go through the given conditions over there in the problem, right? Just see here in triangle ABC, AB equal to AC, DE are the points on the sides AB and AC. See here in this triangle ABC, D and E are the points on AB and AC. That is what given. Now what we need to do here, so such that AD equal to AE. Again we have given what? AD equal to AE. AD equal to AE means this and this are equal. Okay. Now show that BCDE are concyclic. Okay. Now just see here AB equal to AC given. So let me write the proof. What is the proof for this? As we have given, what is given condition over there? Given that triangle ABC, in triangle ABC, we have given AB equal to AC. That means what? This is an isosceles triangle, and I said you before that when two sides are equal, that opposite angles also will be equal. So here this is triangle ABC in which AB and AC are equal, means it's an isosceles triangle. Once again I will draw like this. See here, in the absence of DE you can observe ABC is a triangle where AB equal to AC, that was given and we are using that. Okay, AB equal to AC. Then obviously opposite angles will be equal or not? Exactly. So here this and this angle, this is opposite to this and this is opposite to this. So therefore here these two angles also will be equal. Okay. So therefore angle B equal to what? Angle C. Got it? Angle B and angle C are equal. right? And one more thing. Now see, don't get confused. I'll slowly explain this part. Okay. So see this angle B equal to angle C, and we have given AB equal to AC. No? So just keep this condition aside. Okay. Let us keep this aside. Now take AB and AB equal to AC again. AB equal to AC. Okay. Now if you just look at this, we have given another condition also, AD equal to AE. AD equal to AE. So how can we write this AB and AC? Okay, AB and AC can be split to what? AD plus DB or not? Similarly, AC can be split to AE plus EC or not? Let us do that. So AB can be split to what? AD plus DB equal to what? AC can be split to AE plus EC. So this can be split into AE plus EC. Okay. Now as we have given, now use this condition. We have given that AD equal to E. Then put AE in place of AD. Here AD in place of AD we can keep AE, so we can put here AE plus DB equal to AE plus EC, right? Now tell me, here there is AE on both sides or not? AE is a common term on both sides with the same sign plus, so we can cancel on both sides this. So what is left over now? DB or BD, we can say BD also. BD equal to what? CE, right? So we wrote this, we replaced this AE because the reason was AD equal to E. AD equal to AE. Okay. So now tell me, if you take this AD equal to AE, we took this and we got this. Okay. Now tell me, if you consider this as 1 and this as 2. Now divide 1 with 2. Then what will happen here? AD by BD equal to AE by CE, RHS part. Now just clarify that AD by BD and AE by CE, it will be clarified on seeing the figure. Just observe the figure over there. Now AD by BD equal to AE by CE. Just see this, AD by BD equal to AE by CE. Okay, what did you observe? Here D and E points, or the line DE is dividing here two different sides of a triangle in equal ratio, right? So once again I am telling you, here AD by BD equal to AE by CE. That means AD by BD equal to AE by CE. So this line is dividing these two sides in the equal ratio or in equal proportion. So can we apply the result of converse part of the Thales theorem or not? Exactly. So we can apply here converse part of the Thales theorem. What does it say? When a line is dividing two different sides of a triangle in the equal ratio or proportionately, we can say, okay, then the third side will be parallel to that given line. So here obviously DE will be parallel to what? BC from the converse part of. So DE will be parallel to what? BC. This is from which theorem we said? Converse of Thales. Let me write shortcut here, Thales theorem. Converse part of the Thales theorem says that DE is parallel to BC. Right. So now problem is not over. Okay, just see what we have to do next. Now these two lines we got parallel. Now what is our condition? Our task is to show that BC, DE, ED are concyclic. That means this quadrilateral is cyclic quadrilateral. Then we have to go through some properties of transversals also. What does it say? See here. Since let me explain to you the next part of this problem, and that part would be a transversal property. See here, as we said that DE, this is DE or not? Exactly. This is BC. Okay, this is BC or not? Now if you draw this side AB, it is like this or not? AB is like this or not? Now tell me, if these two are parallels, this is a transversal for those two parallels or not? Exactly. This is a transversal for these two parallels. So that means this AB, side AB acts as transversal for DE and BC. When there is a transversal, then these two angles are called what? Corresponding angles. For a pair of parallel line, okay, corresponding angles made by transversals are equal. So angle B means this is angle B equal to this is angle D, no? This angle D is angle ADE, okay, equal to angle ADE, okay. We wrote same only, okay. Angle ADE equal to angle B because those are corresponding angles. Now from the solution of the equation, process of solutions of the equation, what can we say here? Can we add same number on both sides or not? Exactly. Now do one thing. Here both sides you add angle BDE, angle B plus angle BDE. When you add this side, you have to add that side also. Angle ADE plus angle BDE. What we did here, we added angle BDE on both sides. Which one is angle BDE? Tell me here. This is angle BDE or not? Exactly. BDE. We added on both sides. Right. Angle B plus angle BDE. Okay, angle B plus angle BDE equal to, so write down angle B plus angle BDE equal to. Now tell me, angle ADE plus angle BDE. What is the result of that? See here, angle ADE plus angle BDE means this angle and this angle. So if you just observe, this is in this pattern or not? So this ADE, this is A, this is D, this is E, and this is D. So ADE is this one and BDE is this one, right? So what does it represent? Is it a linear pair of angles or not? Yes. From very basic of lines and angles we learned this. Okay, it's representing linear pair of angles. And what is the property of linear pair of angles? Yes, linear pair. The property of linear pair of angles would be they are supplementary. Means adding those two will get 180 degrees. It's a very simple thing. On adding these two, we'll get 180 degrees or not. That's it. So when these two are linear pair of angles, okay, but then we can say that sum of these two would be how much? 180 degrees. Because of linear pair of angles. Okay, linear pair of angles. Now what did we get here? Angle B plus angle BDE equal to 180 degrees. So now tell me, here take out this. Okay, I will rub this because it is a bit confusing. Okay, now if you observe, what did we obtain? Here angle B plus angle BDE is equal to 180 degrees we obtained. Right? Angle B plus angle BDE equal to 180 degrees we obtained this. Now let us use one of the given condition. Here we have given that angle B equal to angle C or not. Okay, it is given that angle B equal to angle C. Why? Because AB equal to AC. We said that AB in this bigger triangle, this side is equal to this side. So opposite angles are equal, we obtained. So and these two angles are obviously equal or not? Yes. So therefore, okay, angle B plus angle BDE. See this, in place of angle B, sorry, here angle B is there, no? This angle B equal to angle C we said before. So therefore, angle B can be replaced by angle C or not? Exactly. So therefore, angle C plus angle BDE equal to 180 degrees. This is from what? Given condition. Since AB equal to AC. Since AB equal to AC, right? So because AB equal to AC, angle B equal to angle C. So therefore we replaced angle B with angle C. Now what did you obtain? Just observe. Here angle C plus angle BD equal to 180 degrees. Got it? Angle B plus angle BD equal to 180 degrees means what? See here, if this is a quadrilateral like this, okay, B, C, E, D, then angle B means what? Sorry, angle C means what? This one. Angle BD means what? This one. Sum of these two is 180 degrees means what? Okay, here opposite angles in this quadrilateral are supplementary or not? Exactly. So therefore, when this property is holding, okay, then obviously remaining two angles will be also supplementary or not? Remaining two opposite angles also will be supplementary. What are those two remaining angles? Angle B plus angle CED. Angle CED also will be supplementary. So now, did we obtain, okay, our required condition or not? Exactly. Here in this quadrilateral, opposite angles are supplementary. This and this is supplementary, just we obtained, and this are supplementary, that also we obtained obviously. Okay. So here, when these two, once again I am telling you, if this is sum of this is 180 degrees, then sum of remaining opposite pair is also 180 degrees, because sum of all angles in a quadrilateral is 360 degrees. When 180 is over, the 180 only will be left now. So remaining two also obviously 180 degrees. Remaining two sum will be obviously 180 degrees. Understood? So anyways, angle B plus angle CED is equal to 180 degrees. It is over. Now from this, what did we obtain? Our required part is that opposite angles in this quadrilateral are supplementary. Then what I said, this quadrilateral BCED means BCED is cyclic. So therefore BCED is a cyclic quadrilateral. It's a cyclic quadrilateral. When this is a cyclic quadrilateral, then vertices lie on circle. That means what? Those all are concyclic or not? So therefore, we can write. So finally, we can write that B, okay, C, D, E are concyclic. So like this, we can show those are concyclic. So that means here, dear students, observe in this problem is this proof that we are not only using converse of the Thales theorem, we are using the properties of the cyclic quadrilaterals from 9th standard and properties of isosceles triangles also from the 9th standard. So while doing the proof of any theorem, we may use the mixed properties from different topics. Understood? So all the topics are correlated. All the topics are interlinked. So don't neglect any one topic of the geometry, because it will affect another topic. Understood? So anyways, before going to close this session, let me explain to you once again that our target is to find that our target is to show that B, C, E, D, all the points are concyclic. For that we need to show that this quadrilateral is cyclic quadrilateral, and for that we need to prove that here opposite angles are supplementary. That is what our need. And for that what we did, we took the given condition AB equal to AC and we got angle B equal to angle C, because if two sides are equal, that's a isosceles triangle. Opposite angles also will be equal. Those two angles are these two, right? So therefore we obtained this angle B equal to angle C. Now the next part would be AB equal to AC. AB equal to AC, then if we splitted AB to AD plus DB and AC equal to AE plus CC. Since we said that AD equal to AE, okay, we put AD equal to AE here and we cancel AE on both sides and we obtained BD equal to EC. Okay, when we got BD equal to EC, this will be condition 2 and given condition is 1, dividing 1 by 2, then we obtained AD by BD equal to AE by CE. This is clearly representing converse of Thales theorem. So when this DE is dividing in the equal ratio for remaining two sides AB and AC, then obviously DE will be parallel to what? BC. When DE is parallel to BC, which is given, then the D and E are parallel lines. then AB is transversal. Then obviously these two angles, angle ADE and angle B, are corresponding angles, those are equal. For our convenience, we added both sides with BDE, angle BDE. Angle BDE means this one. When we added angle BDE on both sides, angle ADE plus BDE, ADE means this one and BDE means this one. Both are representing a linear pair. And we know that linear pair is supplementary. That means sum of the angles in linear pair is 180 degrees. Okay. So therefore, sum of these two is 180 degrees. So we got angle B plus angle BDE equal to 180 degrees. Now we will take the advantage of one more initial property which is given. Angle B equal to what? Angle C. So we can replace angle B with angle C. So angle C plus angle BD equal to 180 degrees. So angle C plus angle BD equal to 180 degrees means which one of the angles are represented in the diagram? Angle C means this one, that means this one. And angle BD is this one, that means this one. Means opposite two angles are supplementary, we got. When these this pair of opposite angles are supplementary, obviously this second pair also will be supplementary because already 180 degrees is over. So only 180 degrees is left because sum of the angles is 360 degrees in quadrilateral. So obviously remaining two pair of opposite angles also would be 180 degrees. So supplementary. So when two pairs of opposite angles are supplementary in a given quadrilateral, then it is cyclic quadrilateral. When it is cyclic quadrilateral, obviously all the vertices lies on circumference of a circle and they are known to be concyclic points, and we proved it. Understood? So for doing this only one proof, we used three different properties from three different genres of geometry. Don't forget, like this also we need to do problems on sometimes, right? So hope you guys would have enjoyed this problem. You would have understood this. Focus on this type of problems because these are a bit clumsy, right? Anyways guys, if you really like this problem, don't forget to like, share and subscribe. And one more thing, if you get any doubts or if you want me to explain anything else, expecting anything else from us, then don't forget to comment. We'll definitely go through comment session and definitely collect all the valid comments, and we'll try to make the videos on your opinions from the comment section. Thank you.
Please subscribe and don't forget to click the bell icon for the more updates.